Now, I'd like to introduce Matt Pritchard to wow you and pique your curiosity. Matt.
Thanks, Chris, and welcome everyone. In our last session, John mentioned me and said I have a little bit of an obsession with curiosity and wonder. So I also like making things with my hands. This is something I made the other year. What we've got here is some pyramids in an array. And you can see there's some different colors. There's greens and reds and blues. And if I hold it like this, we can see that some of them line up and we end up with the word wow. But of course, there's different sides to this. So if I turn it around 120 degrees, we end up with a second word. We end up with the word how. And then there's a third word, and the third word is written in green, and it's now. And so we end up with this, what I call this cycle of wonder: wow and how and now. And so for this, I use this to think about how I approach my science. What's surprising about it? What makes me go wow? I love that moment of wonder, but also wonder is more than just a surprise. Wonder is also trying to figure things out and explain things and discover more, which is why I move on to the how stage. But then if we stop at the how, we really miss out. How shouldn't be a full stop. It should be a springboard, which is why I've introduced the now stage. Now, what could we do with this? Now, how could we apply this? Now, how could we make the world a better place? So I'm going to show you a video of something I made. I'm going to show it you 3 times. The first time, I want you to look in the mirror and something strange will happen. The second time, you're going to see it, but you're going to get a backstage view. You're going to see behind the curtain to see what's really going on. But then you'll realize it'll happen really fast. So the third time you'll see it, I'll slow it down so you can get a really good view in this. So here we go. Let's. So where does that extra block come from? Let's get that side view. I'm going to show it you in parallel. So you've got the front view on the left and the side view on the right. And that extra block seemed to appear from the table. So let's now slow it down. And you can see there's a string attached, and that string is pulling the block up and folding it into that cube shape. It's what we call a self-assembling net. And so I took something flat and made something 3-dimensional from it. But engineers at NASA have sort of done it the other way. So what they had a problem. When they were launching satellites and telescopes into space, both satellites need large solar panels and telescopes need lots of mirrors to collect as much light as possible. But that creates a really big surface area. So how do you fold up that into a small space? Well, one of them started looking at sort of origami shapes. So what we've got here, and I'm going to just zoom in on this so we can sort of get to have a look at this. This looks a bit like a rose. But what's wonderful about this, if you take opposite sides of this and pull, you end up having this unfold and make a flat surface, and then it rolls up. And so what you can do with this is you can take a shape like this with a large surface area and then put it into a small volume. And so engineers at NASA are taking this idea to launch satellites into space. When they get up there, those satellites will then expand and create the big solar panels, or they will expand and become a telescope. And I just think it's a wonderful idea of them going wow and how and now. So as you've might have gathered from that first video I showed you, I'm both a scientist, my background's physics, but I'm also a magician. So I'm going to show you some science magic in our time together. And this next thing, to be honest, it really just gives an excuse for me to zoom out so you can appreciate my Christmas jumper. So there we go. We've got my tree Rex, but I want to show you a 6-sided shape. So here we go. Ta-da! And I know what you're thinking, Matt, this is just a hexagon. This isn't just a hexagon. This is a blue hexagon. And it's not just a blue hexagon, it's also a red and a blue hexagon. And if we're mixing colors together, we'd end up with purple. So what we've got here is a three-sided shape. We've got a red, a blue, a purple side, but I've also got, and I haven't told you about the yellow side. So we've now got yellow and blue mixed together makes green. There's one last color. I don't know if you can work out what that's going to be. We go back to our red color, and red and yellow mixed together makes orange. And so we've got that 6 colors going on. And it's given a ridiculous name. This is called a hexaflexagon. It's a hexagon shape. So that's the first part. It's 6 colors. So it's got another hex and 6 often used interchangeably. And also we've got flexagon because it folds and it opens up. It's a wonderful shape. Now, talking of color changes, I want to introduce you to this. This is a machine I've made. It's a rather marvelous machine. Let me give you a little talk. So what we've got here, we've got a little cup at the bottom there, and we've got a little pipe that's sticking out here, and we've got a funnel at the top, and obviously a box there, a mystery box. I'm going to pour some water, and I've got just some colored liquid here. It's just been dyed with some food, so we've got coloring. So we've got the blue color. I'm going to pour it in the top, and we'll see what happens. But as you watch this, as you observe this, what I'd like you to do is be thinking, what on earth's going on? If you've got an idea, and if you're watching live, do put that idea in the chat. I want to see what you think. So let's start by pouring some blue in. And if we get a close-up on this, what we can see here is coming out, rather than blue, which we started with, we've got this red color coming out. So we can maybe put a little bit more in, and we can see what happens. So let's put some more blue in. And we've got a color change. So I would love to know, what do you think's happening? So if you've got any thoughts, I'm going to keep my eye on the chat. We might have a few people giving some thoughts, and I know we've got a few of the team from the Discover Materials group watching as well. So maybe they've got some thoughts as to what's happening there. It's very strange. Now, I once did it in a school, and one child thought I'd got a little elf inside the box with a paintbrush, and he was just painting all the atoms because he just heard about atoms, and he thought, well, maybe you could paint the colors of them. So it could be that. It does look a little bit like chemistry, doesn't it? So maybe I've got a color change going on. Thank you, Chris, has just put in the chat box a pH change. pH is sort of a measure of the sort of acidity of a liquid usually. And so maybe what I've done is I've just changed it. Maybe that color change is a reflection that the liquids become more acid or more basic. So it could be that. It could be something else. Let me show you. This isn't chemistry as such. This is more like physics. It's floating and sinking and displacement. So I'm going to give you an inside view of what's going on. So let's get my camera out here. So we'll get up nice and close. So what we can do, we can just start by taking the funnel out. That's not needed. And we've got this here. And if I lift this up, hopefully this will come out. And there we go. What we've got, I'll just move my mic around so we can see a bit. We've got a tub, which has got my red liquid in, but actually in the top here, we've got a second tub. And this is what's been collecting my blue liquid. So the blue liquid is going into the funnel and into this. And as this sinks down, it pushes the red liquid up. And eventually that gets pushed high enough up to push it out through the tube in the side. And so it's just a very simple displacement going on and a change. But it's a lovely, I said, a lovely little mystery as to what's going on. And maybe you could think of different ways you could do that as well. pH change would work. Oh, I've just seen that John has mentioned, maybe it's oil, maybe One of the liquids floats on top of the other because of the density of liquids. So it could be oil. There's another way of doing it. I love the fact there's always more than one way to do things. And this is, like I said, that box is a lovely mystery box to get you thinking. Now, we're in a winter season and we're having a winter day today. So I want to show you a lovely little thing you can do at home if you've got access to a whiteboard marker. So it's going to get a bit of a top-down view. So I'm just going to move my camera into place. And what we're looking at down here is just a white plate that I've just raided from my kitchen. And what you'll realize is I'm a terrible artist. So I'm going to attempt to draw snowflakes, but just humor me on this. So I know you've got this six-fold symmetry with snowflakes. I've got my 6 lines. I'm going to do this. It's not got the same beauty of the fractal patterns you do get with proper snowflakes. Oh, just one more there. So I've put the pen and I'm going to give it a moment to dry. And then something remarkable happens when you start adding water to it. So I've got a big bottle of water. We can add that to this. And I'm just pouring the water, just make a little puddle on top. Now, what's not happened is the ink's not run. I think lots of people think that the ink is going to just very quickly sort of mix in with the water and you just end up with this this white color. It's not that. I don't know if you can just see down here. I'll give you a tiny close-up on it. On one of them here, actually where the ink was on the bottom of the plate has started to lift up. Let's see if we can get it all to. Okay. Come on. I'm completely destroying that snowball. So I'm just going to grab a ruler and we'll see if we can do a better version of this. Just gently peel it up. There we go. It's starting to lift off. And I'll do the others as well. You can take a bit more time doing this. Really what you need to do is make sure these have a bit more time to dry. I'm just completely butchering my artwork already. We've got one though, that's floating quite nicely just down here. And it's just lifted off and you can get this lovely pattern. And the rest of it's not quite as elegant as I'd like it to be, but yeah, it's lifted off there. So it's a nice winter themed little demonstration you can do with some materials. Okay, the next thing I want to show you is involving some more water. So I'm going to move my plate to one side and we're going to do a little bit of an observation here. So I've got my glass of water and I've also got a bright pen. And this glass of water is acting like a lens. So if we were to put this behind it, you can see a few things that are happening. You can see how the pen has been bent and it's been distorted. So the text there has gone really strange there. It's no longer straight. It's been magnified. It's definitely a bit bigger than it was before. But this is the thing I really want to show you. If you take a pen and move it to one side, you enter what's called a blind spot. And if I move it the other way, it enters another blind spot. But this is really strange because what you've got here, horizontally, you can see the pen. Vertically, you can end up entering a blind spot, which is just like really nice, or have them both vanish that way. And I love asking the what if question. So I just made a pen disappear, but what would happen if we had a bigger tank of water? Could we do some other things? So what I've got here is something I've pre-recorded with a much bigger glass of water. You can see the scale there with my hand. And I've actually managed to hide 2 cans of Coke behind a glass of water. That's about that wide, that much of a diameter there. It's amazing what you can do with the way the light is distorted. and it actually hides it and you cannot see it. Now, you might have not got a big glass of water, but what you can do is you can make an invisibility cloak by using more than one glass. So what I've got here now is 5 glasses. Again, I'm going to use that stick to show you that you can see through it. And then suddenly, oh, look at that. We've got the word invisible. So let's just see that again. And I'm going to pause it as we go halfway. So it's not frozen at this moment. I've just paused the video. You can see the word invisible has been made up of 9 letters. There's 5 glasses. Each of those glasses has got 2 blind spots. And so you can hide those 9 letters in those 10 blind spots made from that invisibility cloak, which is nice. But we can do other stuff. So what I've got here now is a second glass. And I've got the word, well, the letters O and N there. And we're just going to see what happens when we place this into here and put some water on. So I'm just going to pour some water in. And again, we've got this magnification going on. It's got a bit bigger, so we've got a larger O. It's got so big, though, that the letter N has been pushed off to one side and it's entered a blind spot. You can't see, and if I twist it this way, well, we can see the letter N and the letter O's disappeared. If I leave it in the middle, you can see a bit of both. So the other way to do this is just to move the camera. If you move it to the side, we end up with switching between those 2 letters. That's a bit boring, switching 2 letters. It's a very basic animation. But if you use lots of glasses, then you can do something like this. So I've set this out on my decking and we can switch between 2 words now. The angle affects what you see and you just switch between the 2. And so you can make that up. If you want to scale it up further, you can maybe use sort of 2-litre bottles, clear bottles, fill them with water, and you can make even bigger words disappear. Make your own invisibility cloak. I'm going to show you a video, something I made last year with a real Christmassy theme. It's a magic trick, but I think I've told you enough to give you a hint as to something that's going on behind the scenes, but I will leave the rest of it as a mystery for you to work out. So here we go. So let's see that one last time because it's only a 10-second video. We seem to have a very mysterious switch that somehow the snowman has gone and turned into Father Christmas. Or maybe I've been using some of the properties of light being bent as it goes through a glass to help me with that. Before we move on away from looking at glass and water and light being bent, I'll show you a few other things you can do. So for this, we need a bit more water. So I'm going to lower my camera. So I've got a bigger tub here. I'm going to fill this up with water. But before I do, let's put into place an arrow. So the arrow is going to go like there. And you can see the arrow through there, and the arrow points to the left. And let's see what happens when we put some water in here. And the water not just distorts it, it also changes the arrow's direction. And so what we've got is a complete reverse. We've got arrow pointing to the left. Through the water, it's been flipped and it points to the right, which is nice. But I love a challenge. How many flips can you do with a arrow? So let's see. This was me here. This is 3 glasses. 3 glasses we've got to the right, then to the left, then to the right, and then to the left. And so maybe over Christmas, you could try that. Make yourself a nice bold arrow, line up some glasses, and you need to make sure the glasses are separated. They need to be one focal length apart, which means the arrow is not being magnified, it's not being shrunk, it stays the same, it's not distorted as much that way, and see what you can do with that. So there's another thing you can do with water and glasses. And this is another blind spot. So I'm again getting my camera into the right position. This time, rather than looking through, what you need to do is you need to look down onto it. So I've got a downwards view now, and I'm going to start with the word vanish. Now, vanish is in a black frame, and if I place vanish down, vanish actually vanishes. We end up with the words living up to its own name, or what we've got here is my self-portrait. Again, you can see my artistic skills coming through. We put that down, and most of my features disappear and pop up. Something very strange is going on. And to try and understand this, what I need to do, I'm going to just grab two plastic glasses. Here we are. I've got two plastic cups. I've got a triangle here, and I've also got a little sailing boat. And the reason I want to show you that is you may have heard of the myth of the Bermuda Triangle. It's this idea that when a ship goes into a part of the ocean that forms a triangle between Miami, Puerto Rico, and Bermuda, in that region, that triangle connecting those three geographic points, there's meant to be a lot more mysterious disappearances of boats and ships. And so there's a bit of a folklore that if you go into this region, you're in danger. It's not true. It's no more dangerous than any other place in the ocean, but it's inspired this. So we've got my cup with the boat in. If we have a look at this, when it goes into the water, we can see that the boat within the Bermuda Triangle, within the water, has vanished, but it's still there. It's just that strange angle looking down with the light being bent. And the important thing this time is we've got the two cups, and there's a gap between the two cups. There's an air gap. So you may know that when light passes through materials like water, like plastic, like the air around us, then each time it changes from one medium to the next, between like water and air, or plastic and water, or plastic and air, the light gets bent, its direction changes because the speed of light's affected. And what's happening because of that little air gap in the middle between the cups, some of the light that's hitting the inner cup is being bounced away from the camera lens. And so it looks like it enters an invisible spot. What I did earlier with my words vanish and my self-portrait was, rather than do cups, I laminated two sheets of plastic, sandwiched together, but with a bit of air between them. And by doing that, when the light hits the outer surface, which is the black frame, it goes to the camera lens. When it hits the red text, which is on the inside, beneath that air gap, it gets bent in a different direction away from the camera lens, and then looks like it vanishes. Now, some of you will be familiar with David Copperfield. David Copperfield is a Las Vegas magician, and way back in 1988, he went to the Bermuda Triangle and he filmed one of his big TV specials. And he disappeared into a yellow pyramid, and then a few minutes later, he appeared in the middle of the Bermuda Triangle with a big surprise. And I love the challenge of taking big illusions and scaling them down. I love incorporating Lego into my work. So I'm going to show you a recreation of David Copperfield's famous Bermuda Triangle illusion. So let me just find where I've hidden that particular one. It is somewhere here, he says. I completely moved all my videos around, and so it's not quite jumping out to me straight away. Where have you gone, Bermuda Triangle? Which is so ironic that I've lost the Bermuda Triangle in this. And if I cannot find it, we will move on to the next thing, which I'm really excited about. So let's see, it doesn't seem to be there for some strange reason. So what I'm going to do, I'm just going to show you the yellow pyramid, the start of it. Oh, in fact, stop that. I have finally found it. Here we go. So there we go. An understanding of optics and understanding of materials has allowed me to recreate that illusion without using any sneaky camera edits or hidden helpers to make that grand illusion on a small scale. The last thing I want to show you is something that I've been playing with this last week. It's something that I thought I discovered brand new, and sadly, chatting to some of my friends, one of my friends, Neil, says, yeah, Matt, I know about this. I do this all the time, but I really wanted to share this with you this afternoon because I just think it's such a cool application of materials and also light, which is a big theme of what we've been sharing in the last half an hour. So what I've got here is, well, there's my face. And behind my face, we've got a black piece of plastic. So what you're looking at right now is the black piece of plastic and my face under visible light. But of course, you may know that light isn't just visible. There's light in the infrared, there's light in the ultraviolet, and further than that. But our eyes can't see it. However, some of our technology can, and there's a really lovely way you can do this. So I've got a second webcam here, and earlier last week, in fact, I bought this. It's a very cheap webcam, and the first thing I did once I checked that it worked was I took it apart, and underneath the lens, and before it hits the sensor on the electronics, most cameras have this. I don't know if we can see it. It's just in this plastic. It's that sort of pinky square there. That's what we call an infrared filter. And what it does is it cuts the infrared light that is all around us from hitting the camera, the webcam. And so all the camera is doing is picking up on the visible light. So it just reproduces what we're seeing. But because I've removed it from this camera here, this camera will now be able to see into some of the infrared. And the other thing I've got here, this piece of black plastic is actually transparent in the infrared frequencies, which means this camera that you're looking at right now can't see anything. But if I was to switch to a different camera, so here's my one that I've adopted. Let's move my face for a start. You see that this camera now, so the main picture is the infrared camera. That's got that purpley haze. And the other one in the top left, that's the visible one. And what you can see there is behind the plastic, we've actually got our winter penguin there. And I'll put it back. And it's like the camera can see through objects. It effectively is. It's just seeing the light that our human eyes cannot see, which is fun. I'm going to make it a bit brighter. I'm going to add another light. This light is an old desk lamp. So it's got a filament in, it gives off infrared light, just makes it more transparent. And just to finish with, here's my face. Let's see what my face looks like behind here. And look, a bit like the vanish and the self-portrait before, it actually, there, it disappears. That's because different inks absorb light in different ways. And some of the ink I used was absorbing the infrared light and some wasn't. And then you end up with that very strange effect of some of it just vanishing under different light. And so that's everything that I wanted to share with you this afternoon. I hope you've had fun. I hope you've had a few surprises. I'm going to just hand you back to Chris now.
Oh, thanks very much, Matt. That was absolutely fantastic.